Hi everybody. So in this video, we're going to look at performing successive transformations using matrices. In our first example, we've been asked to find a 2 by 2 matrix, matrix T, that represents a reflection in the x-axis, followed by a rotation of 90 degrees anticlockwise about the origin. So the first thing we need to do is to identify the two transformations. We've got a reflection in the x-axis, and then a rotation of 90 degrees anticlockwise about the origin. And we need to find the transformation matrix for each of these transformations. So we'll have a reflection in the x-axis and a rotation of 90 degrees anticlockwise about the origin. So to find each of these transformations, we need to use the unit-based vectors I and j. If we look at this one first, when we reflect this I component in the x-axis, this becomes invariant, which means it's reflected onto itself. And when we reflect the j component, this is transformed onto 0 and -1. So this gives us a reflection matrix of the images of I and j, so 1, 0 for I, and 0, -1 for j. And then for our rotation matrix, if we rotate this I component 90 degrees anticlockwise, then this is rotated to where j currently is at 0 and 1. And when we rotate the j component anticlockwise about the origin, this is rotated to -1, 0. So this gives us a rotation matrix of the image of I, so 0, 1, and the image of j, -1, 0. So now we have our two separate transformation matrices. We can combine these together to find matrix T. So the first transformation we're applying to T is the reflection in the x-axis. So the way we write this is that T is equal to reflection in the x-axis, so 1, 0, 0, -1. And then we write the next transformation to the left of this. And this is our rotation of 0, 1, -1, and 0. And then I'll just move this a bit closer. So now we can work out T as a single 2 by 2 matrix by multiplying these two together. And I'll do this on our calculators. So we'll go to our calculators. We'll choose menu and option 4 for matrices. Then we'll define matrix A, so option 1. This has 2 rows and 2 columns. And this has the elements 1, 0, 0, and -1. Then we'll define matrix B. We'll choose option 2. Again, 2 rows and 2 columns. And this has the elements 0, -1, 1, and 0. So now we need to multiply these together. So we'll choose option 3 for matrix calculations. We want matrix B multiplied by matrix A. And this gives us our 2 by 2 matrix of 0, 1, 1, 0. Okay? So in our next example, we're going to look at combining 3 transformations. Okay, so in this example, we've been asked to find a matrix that represents a rotation of 90 degrees clockwise about the origin, followed by a reflection in the y-axis, and then followed by an enlargement with center 0 and a scale factor of 2. So perhaps you want to try this question yourself. You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you had a go. So if we identify the 3 separate transformations, we've got a rotation of 90 degrees clockwise about the origin. We've got a reflection in the y-axis, and we've got an enlargement with center 0, scale factor of 2. And we need to work out each of these separately using the I and j unit-based vectors. So if we begin with the rotation, we'll rotate the I component 90 degrees clockwise, and this is rotated in this direction. So this image has coordinates 0 and -1. We'll rotate the j component 90 degrees clockwise. This will land here with coordinates 1, 0. So this will give us a rotation matrix of 0, -1, 1, and 0. Moving on to our reflection, if we reflect I in the y-axis, the image will have coordinates -1 and 0, and this j component will be invariant. So the image will also have coordinates 0 and 1. So the reflection matrix will become -1, 0 for I, and 0, 1 for the image of j. For our enlargement, if we enlarge I by a scale factor of 2 from the origin, the image will have coordinates 2, 0. And if we enlarge j by the same enlargement, the image will have coordinates 0, 2. So this transformation matrix will be 2, 0, 0, 2. So to find the single 2 by 2 matrix that represents the succession of these transformations, we'll say that M, and because we're applying the rotation first, this goes furthest to the right, so 0, -1, 1, 0. And then we apply the reflection, which comes to the left of this, so -1, 0, 0, 1. And then we apply the enlargement, which goes to the left of that, so 2, 0, 0, 2. And M will be the product of these three 2 by 2 matrices. We'll label this one as matrix A, the reflection as matrix B, and the enlargement as matrix C. Then we can work out this product on our calculators. So we'll define matrix A with 2 rows and 2 columns, and elements 0, 1, -1, and 0. We'll define matrix B with the elements -1, 0, 0, and 1. And then we'll define matrix C with the elements of 2, 0, 0, 2. So then our calculation is matrix C multiplied by matrix B multiplied by matrix A. And this gives us our single 2 by 2 matrix of 0, -2, -2, and 0. Okay? Well, thank you very much for watching. I hope that's given you a clearer idea on how to combine multiple transformations using matrices. If you did find that helpful, please like and subscribe, and you can download the full lesson and worksheet from my website, mrmathematics.com. I'll leave a link in the description below.